G'day everybody, welcome to my channel. My name is Driekus. I am from South Africa. I love all things homesteading and sustainable, and I've noticed that people are afraid to build their own small solar systems. I'm not talking about large home solar systems. You need a little bit more experience when you approach a task like that. This video is just to get you started, or maybe give you some insight into how a small solar system works, and empower you to build a small solar system for your homestead or your RV camper van. Okay, so I'm going to start with the solar panel. There are quite a few solar panels and sizes that you can look at. Mainly you've got a solar panel for 12 volt system, which is around about 17 volts to 22 volts. These panels often come in sizes of 100 watts to 250 watts. These are normally used for 12 volt systems. However, you need to think of the environment where you're going to put the panel, and if that's going to be sufficient for your needs. You need to remember that the maximum wattage of the panel is not what you're going to get. That is the extreme direct sunlight. You will get only 6 hours of 250 watts in this case, because the sun won't shine on the panel directly, etc. Then you get larger panels, which normally start in the range of 50 volts, and they are 400 to 550 watt panels. You can choose either, but you need to choose your charge controller correctly. The panel has a positive and a negative. Make sure you check that, and make sure that you use the right wire coming from the panel. You will connect your panel to your charge controller. Now it's got an in and a output, a positive and a negative, a positive and a negative. You will directly connect your solar panel to the charge controller. You need to make sure that your charge controller voltage range is correct. This is very important. For 12 volt systems, you normally have a voltage range of 0 to 30 volts. You will use this kind of charge controller for the smaller solar panel. Make sure that your maximum voltage, input voltage of your charge controller, is always higher than your maximum voltage of your solar panel. If you want to use a higher voltage solar panel, you need to look at a voltage range of 0 to 75 for one panel, or 0 to 150 volts. Also making sure that your maximum voltage is always higher than the maximum voltage of your solar panel. Right, so what does a charge controller do? It brings the maximum voltage of the solar panel down to your battery voltage. You get two different kinds. You get a MPPT, which is a maximum power point tracker, and a PWM, which is a pulse width modulator. There's the difference between these two. The MPPT will charge at a constant rate and regulate the voltage and current, where the PWM charges at a pulse. This one is more efficient. They are slightly more expensive, but this is definitely the rate to go. You also get them in a Bluetooth module unit, where you can connect with your phone and you can change the charge voltage, and they're just nicer to have to check your status of your battery. Right, so from here you will have an out charge controller, from your charge controller to your second battery. I'm saying second because I'm going to go to the starter battery of the vehicle later, but this is basically your secondary battery, positive and a negative. You will connect the output of your charge controller to your battery. Now the wire thickness here is very important, and I'll come back to that later. Sorry, this is not the wire thickness, but you need to check the gauge of the wire in all cases. In other words, you need to check what gauge you're going to need for the maximum output of the solar panel and the maximum output of your charge controller to your battery. Okay, now from here you will have a inverter. The inverter also has a input and a output. This is the battery. From here to here you have a direct current. Direct current power is shown as a straight line. The inverter, you have your input coming from your battery. Here your gauge, your wire gauge is very important, and I'll come to that in a minute. Your inverter converts the DC power of your battery to alternating current, AC power. AC power is 110 for Americans, that's voltage, to 220 for most of the rest of the world. Right, in this conversion process there's a loss of power. Now I'll come to that now and why I'm mentioning that. So your output here, your positive and your negative again. This goes to your load, which I'll show as a little light bulb. This can be your lights or your camping fridge. Most camping fridges will use 12 volt, and for that you can draw your power directly from the battery to your load, which is either your fridge or your lights. For the 12 volt system, you just need to make sure that you have 12 volt lights, and for your 220 volts you need 220 volt bulbs or lights. Alright, so that's basically it. To choose your inverter, you will look at how much power you need. Now for 12 volt inverters you can get anything from a 50 watts to a 3000 watt 12 volt inverter. Most people won't need a 3000 watt inverter for a 12 volt system. If you use a 3000 watt inverter at 12 volts, you need a very thick battery to inverter cable. It's thicker than your thumb. If you're going for a 250 watt inverter, which is normally more than enough for your cell phone charging or anything that needs a 220 volt alternating current, you're going to need 25 mil gauge wire, which is size of your pinky. It's more attainable and it's more cost effective. Depending on the length of this cable can be very, very expensive. Now your charge controller, the function of your charge controller is to bring down your maximum voltage of your panel, whether it's 22 volts or 50 volts, down to the battery voltage. Now a battery is called a 12 volt battery just because it's the average, but it can range anything from 9 volts to 14.6 volts fully charged. So this regulates that voltage or that voltage down to your battery voltage, stopping your battery from exploding. Now you want to charge your battery, your secondary battery, from your alternator. You can keep your solar system, solar panel on your roof, whatever the case may be, and you also charge it from your alternator. Now here you have your starter battery, and another charge controller. Slightly different to this charge controller. This controls the flow from your secondary battery to your starter battery in different ways. Now here you will have a in and a out on your charge controller. You will connect your starter battery to the in and your secondary battery to the out. The way this regulates charge from your starter battery is in amps, which is very important for lithium phosphate batteries. Lithium phosphate batteries absorb energy way quicker than the old school lead acid batteries, which could overexert your alternator. The flow control of this charge controller also stops you from draining your starter battery. So let's say you're stationary and you're using your fridge and your lights from this battery. This will block the flow of energy coming from the starter battery and trying to keep up with the secondary battery. So it'll always keep the starter battery at 100%. It will also make sure that your starter battery is fully charged before it starts charging your secondary battery. So you don't charge two batteries at the same time and your alternator is very happy. You can overexert and burn out your alternator if this is not regulated. I think that's it. I hope this was helpful. Hopefully you'll come confident enough to go and buy the items and set it up, preferably on a table, on a bench. See how it works before you take the step and install it either in your homestead or in your camper van. Once you get there, it all starts making sense, and you'll figure it out as you go. Don't let this graph make you feel nervous. You can't really do anything wrong. You can only learn a little bit. Like and share the video, and look out for the next content.